Welcome to Plastek's 2022 Academy. This is number 5 in our series. Change is inevitable, and while it can be challenging, we come to admire it. Evolution comes with personal development, innovation, and means of implementation. In some case of change, it's not always about researching to find the right resource. Sometimes it's about creating the right resource. This concept has been impressed upon Plastek for family generations. We will continue to invest in generations to come and the benefits through aided support from neighbors and community partnerships. Today's webinar is presented by Penn State Behrend. With a prestigious reputation, they are the leader in the education. As an outstanding resource for personal development, they continuously to invest in their library of knowledge. Turning it over now to our friends at Penn State Behrend, speaking Plastek's efficiency, improvement through mechatronics.
Good morning. My name is Johannes Heile, and with my colleague Greg Dillon, we'll be talking to you about plastic efficiency improvements through mechatronics. A little bit about myself. I have 20 years plus experience in industry. Now I teach at Penn State Behrend, both industrial engineering and business courses. Our approach today in our discussion is to give you a little bit of context, what we'll be discussing with you, and just to be on the same baseline, we'll give a working definition of mechatronics, and with my colleague, then we'll talk about application and industrial Internet of Things. To frame our conversation, we have gone through 4 now 5 different kind of industrial revolutions, starting from Industry 1.0, focused on mechanization, and Industry 2.0, mass production, and Industry 3.0, automation, and the 4th industrial revolution, which is significantly impacting mechatronics, as Industry 4.0, and now we are at the cusp of Industry 5.0, focused on sustainability, resiliency, and human-centered. To give you the big picture on Industry 4.0 and its correlation with mechatronics, some of the big hitters in Industry 4.0 are automation, and mechatronics is at the baseline for automation and data flow, data from sensors and processes and human input, data being gathered and being applied or value extracted from it. And additive manufacturing is also another key component. I will not address each one of them, but just to give you an idea of the big hitters in Industry 4.0 vis-a-vis mechatronics. And what makes mechatronics more productive is this amalgamation of the virtual and the physical world. Using data to create value, using automation and controls to optimize process operations, whether it is hot runners, whether it is injection molding, temperature control, the amalgamation of the digital or the virtual world and the physical world, this convergence has significant impact on the plastics industry. A brief one, Industry 5.0 will not be discussing that in detail, but as you see, 3 key components, and this 3 key factors will have impact in smart manufacturing in general. To define mechatronics, this is a working definition that I am using. It is a synergetic collaboration between mechanical, electrical, engineering, and information technology in the design and production of industrial products, and also optimizing the design process. That's the working definition that we are using for mechatronics. So mechatronics plus mechanical engineering plus electrical engineering and information technology gives rise to capabilities to smart manufacturing or digital manufacturing. Here where you have end-to-end data flow and where processes are live optimized, whether you are using a PLC or a dashboard to view or visualize the data and make real-time optimization. So the value of mechatronics is capturing data, converting it to information and knowledge and to dynamic understanding. Here we can use descriptive or predictive or prescriptive analytics that gives rise improved quality, customization, and improving the cost position, and which also leads to productive growth, and as it pertains to the workforce change in or upskilling. I think that's the better word to put it, upskilling of the workforce to get a better understanding of data flow and embedded software that is becoming a differentiator in mechatronics and also in the plastics industry. So the markers of mechatronics are data flow, embedded software. Embedded software has the ability, especially in the plastic industry, to differentiate the capability of the product from not only from the hardware design, but attribute reconfiguration to make the product more value added. And also it gives an added controllability and improves interoperability and also configuration and also condition monitoring, machine condition monitoring. In terms of application, if you can see that in the plastics industry, if you have heaters, cylinders, chillers, and fans, and they give rise to temperature control, pressure control, flow rate control, and position control, which are key control variables in the plastics industry. In terms of application, you have the integration of autonomous systems like robots and automated supply chain, and also the predictive maintenance sensors that could optimize OEE and also TEP. I will speak briefly on that. In terms of the outcomes or the applications of mechatronics, it is improving efficiency. As an example, a 2019 survey in the Canadian plastics industry, 50% of the companies that saw growth in their businesses have a significant implementation of mechatronics. So it is, when we say efficiency improvement, it is measurable efficiency improvement. In terms of quality, also quality improvement arise from the capability to view quality as a multivariate system as opposed to single stage or single point quality. And in terms of process repeatability, that the process could be repeated, and improving reduced failure rate, which can be measured, and also improving the cost position, again, which can be measured as a function of the failure rate or mean time between failures. This is how the automation pyramid works together with mechatronics. More and more sensors are equipped, or hardware, software on the chip capability, where they can capture information and also do pre-processing or early processing of information that creates value. So what are the outcomes? In general, it's improved multi-stage quality, improved capacity utilization, whether it's overall equipment efficiency or total effective equipment performance, which can be actually quantified, and resource utilization, and also in the plastics industry, optimizing energy use. So in terms of the value flow, you have sensors, or the information flow, sensors, connectivity, data, and active control of the manufacturing process. So this gives rise to the industrial Internet of Things, which my colleague Greg will be talking with you next. Greg.
Okay. I just need to see if I have control here, which I think I do. Okay. So my name is Greg Dillon, just a quick introduction. I'm currently the chair of the Polymer Engineering and Science program at Penn State Behrend, which is actually a very new program. It was only approved by the university in 2020, and it really arose out of the Plastics Engineering Technology program. Basically a stated need by industry that there was a room for graduates who have a greater materials background, polymer science background. So that program was approved in 2020. But I maintain a faculty position in plastics engineering technology, which I've taught in a number of times over the last several years. I actually have a long history with Penn State. So I first worked for Penn State in 2000. So I left for a brief amount of time, but I'm coming up on 20 years of service to the university. What I wanted to do was basically springboard off the definition of mechatronics, and particularly robotics and automation, that Johannes had gone into. There's a lot of slides here. I have no intention of going through all of them in detail. I'm a professor, so I can't help myself. I put a lot of information on my slides, and a lot of it I'm just giving you for completeness sake. There's basically two things that I wanted to do. Number one is I kind of wanted to broaden the definition of mechatronics to include the industrial Internet of Things. I wanted to talk briefly about the perceptions of implementation and the actual implementation of mechatronics and IoT, as we call it. And also give you a kind of our snapshot of where we think implementation of the technology areas is at, and what are the potentials going forward. So quick definition stuff. This is what professors do. Okay. So there's really a kind of a mapping between the Internet of Things, which I think the general public is actually getting pretty comfortable with that technology right now. So this is like the personal data coordination of different devices. So it's the communication between different devices, smart devices. So the simplest example is you could use your cell phone to turn on the lights in your house. The industrial Internet of Things has, comparable or analogous features or focus areas to its implementation. And a few of these are actually really important. So for instance, when it comes to output, which is really an element of efficiency, when it comes to the Internet of Things, what it does for you is it creates convenience, which actually creates time, right? So it gives you more time. Although I could argue that having extra capability will allow you to, kind of fall into a time sink, but basically time, which is convenience. Whereas in the industrial realm, you're really interested in economic growth. You're interested in improving the productivity of your factory. So on the one hand, you have the personal implementation of the Internet of Things, but then you have the industrial Internet of Things, which in its, most complete embodiment would be what we call the smart factory, where everything is kind of connected with each other. And so the smart factory basically is focused on manufacturing equipment. In the end, it's kind of the ultimate goal is the lights out manufacturing, right? Where essentially the factory runs itself. And it can do that and only do this through intelligently networked devices and sensors. The ability to collect a large amount of data and then to use that data to control critical processes in the manufacturing enterprise. So in essence, it gives you a predictive capability, right? What's going on in my factory? What am I processing? And then the ability to predict if new orders come in of whatever variation in design that they might have, is my factory going to be able to take care of that? So, you know, the power of the prediction is what it gives you is many different things. And I just highlight, it can, in its best implementation, could allow you to pinpoint the problem without actually putting feet on the floor, right? So, you know, is it a service request that's required? Are we having a backup in materials? Do we have materials that are ready to move into the production process, things like that? And a lot of effort over the last several years has been put into location tracking. I'll define that a little bit better as we go through, but location of everything. So that's location through your supply chain, through your factory, and even on to where the product gets to deliver to your customers. And so the benefits are time savings, money savings, and safety. Turns out that safety is a major concern. But the challenges that you'll see from a number of different sources here are really all about buy-in. The technology is out there. I mean, there's, you know, when you can see what you can do on the personal scale, just with the Internet of Things, you can see that there are probably capabilities out there that still extend beyond our imagination, right? So a lot of it is buy-in, a lot of it is training, right? So what you'll see in our survey and a similar type of survey that was conducted in Europe, that training and buy-in from the workforce is actually one of the barriers to implementation of mechatronics, robotics, and the Internet of Things. And of course, that really comes down to, am I going to get anything out of it? In other words, the return on investment. So really, there are opportunities there, and the opportunities really manifest best as optimization of production efficiency, right? There's no sense making all of this investment unless you're actually going to get something out of it in the bottom line. And so I've mentioned the smart factory before, and, you know, this is, you know, we talk about lights out manufacturing, where essentially a plastics plant can run 24 hours a day, minimal human supervision, right? Alerts when the human needs to get involved. That's kind of the ultimate embodiment of what we would call the smart factory. And so those are the opportunities, right? But basically the challenge is, how the heck do you track all of this data, right? So the amount of sensors that exist on the planet exceeds the human population, right? And that's only going to get more exaggerated as time goes by. So organizing the data, how do you import the data, right? Am I collecting the right data, right? Is it sensing data that I need to have, or is it controlling data that I need to have? And then training, right? Am I training my workforce, or am I using the data to train my machines, right? So topics like machine learning become extremely important. And so the enabling technologies, I mean, you're probably well aware of this. So cyber physical systems, very important. Cloud computing, which is, I'll be frank, I really don't fully understand, you know, all of the data that actually exists in the cloud, or more importantly, that can exist in the cloud. And then big data analytics. We have a data analytics program that is actually starting at Penn State Behrend. Okay, it's a new Penn State program. And it looks at all aspects of how you crunch big numbers, how you extract trends, how you extract essentially the texture of a data set to get you something realistic. Because one of the concerns that many people who are interested in this field have is that you have so much data that actually becomes useless. It becomes, and then, you know, the capability that you need to crunch the data exceeds your current production capacity or your production investment. And obviously, artificial intelligence and machine learning is going to be an ever more important part of the implementation. I just wanted to actually stop on this one for a little bit. So there are many different impediments to implementation of the smart factory and mechatronics, robotics, and the Internet of Things. But it turns out that among many companies, the primary concern is security, right? So I said that cyber physical systems are a really important part of taking this to the next level, right? Well, I mentioned the word cyber, right? So within companies, that creates an immediate concern. I'm willing to bet that there's probably some companies who've actually gotten hacked, who've been attacked, right? And so if all of your data and all of your production methods and all of your production control is actually resident in a location that actually can be hacked, that creates a major, major concern for companies. And so of all of the impediments, this is the one that was cited most frequently, which I found that a very interesting finding. So there it is, cybersecurity, a major, major component of implementation of Industry 4.0, which Johannes had talked about a little bit earlier on, and the industrial Internet of Things. Interesting finding, I definitely thought. And you know, there are different activities that the manufacturing base, this isn't just plastics, by the way, but the manufacturing base are actually conducting, right, for cyber and manufacturing. And so 63% are conducting IT risk assessments. So there you have it again, you know, what's happening to my data, how vulnerable is my data. Obviously the other areas or the other factors that are highlighted here also have relevance to that one factor, right? And so what kind of platforms are out there that will allow you to achieve this type of integration? This is just a few, okay? Some of you may have come across other platforms that you can use, but I think there is definitely a market out there, a growing market out there for different platforms that will make this whole implementation a little bit more convenient. And so, you know, how are we doing so far? These are typical of the types of things that broadly are happening in manufacturing, broadly, not just necessarily the plastics industry, but you know, more equipment with sensors, connecting machines to the internet, right? Acquiring cloud computing software. And broadly, the benefits seem to be there, right? So for instance, companies are seeing a reduction in scheduled repairs, right? And how long that takes, reduced maintenance costs, and then fewer breakdowns, right? So this is like what we call broadly, I spent a lot of time in the defense industry, what we call condition-based maintenance. So this is rather than waiting for your machine to break down, you actually monitor the critical components of the machine and try to predict, you know, when an error or when a breakdown is likely to happen. But so, I mean, the data is there to show that there is some return on investment. Not as broad an amount of data as you might think at this stage. But, you know, this is an industry that's expected to grow globally. And the thing I would highlight on this slide is I think the companies that are going to do the best in implementation of this technology, that are going to get the greatest benefit, are the ones who are willing to think outside of the box, right? So by that, I mean non-standard implementation of mechatronics, robotics, and IoT. So really implementing technologies that are specific to your operations, but are also specific maybe to your sector as well, and maybe even specific to your supply chain and your customer base, right? So I think that that's probably where the opportunities lie internally, is doing an analysis of that type. And by the way, you know, Behrend is really getting involved with this, with substantial support from Plastek. Actually, we are establishing a robotics lab, a mechatronics lab, and we're trying to implement various ways of getting students involved in this whole area. Definitely, you know, pertinent to the plastics industry, but basically to try and create an educational enterprise that provides the types of skill sets that companies are likely to need. And so, you know, we've already talked about the challenges and opportunities. And so, you know, I just wanted to finish, by the way, with a focused survey that actually was focused particularly on the plastics industry, and give you an idea of what we learned from that. Now, this is really hot off the presses. And so these are the basic findings. We're definitely seeing process efficiencies in the plastics industry. And I'll tell you the types of technologies that have typically been implemented up to now. But we lag, right? So Germany, Japan, and other countries, particularly in Europe, they've kind of taken a lead, which, you know, as a proud American, I know I might not necessarily sound like one, that's something that bugs me quite a bit, right? I think the basic components of Industry 4.0 and Industry 5.0 were developed in this country, and we're allowing other countries to take an advantage, to take a lead. But there are significant barriers to the US plastics industry implementation of these technologies, but our take on it is that they can really all be overcome. And some aspect of that success might rightly involve collaboration with academia, which is, you know, I have quite a bit of industry experience, but I've seen some very good examples of how collaboration between industry and academia has really broken down barriers to implementation. Okay, and one thing, the point at the bottom there is, you know, we sent out this survey to many different companies, and we got a pretty poor response rate. Okay, which I'm sad to say probably tells a story in itself. Won't dwell on that. But, you know, here's what we learned about what is typically implemented. So robotics, you know, if you're in the plastics industry, you don't need some professor from Penn State telling you that robotics have been implemented in the plastics industry quite a bit. So this is, you know, the pick and place type of robots that remove the part or collect the part as it's coming out of the mold, but also maybe also packaging and assembly robots. They tend to be number one. So they tend to be the major implementation. Process sensors as well, understanding where the pressures actually are being generated in my mold. We see quite a bit of that. Automated guided vehicles, which are really a kind of a you know, a production flow or a process flow expedient. Some fair amount of activity in automation of color blending and material loading systems, and I'll talk very briefly about that. Assembly equipment, obviously, that's a really important one. You know, taking plastic parts and either feeding them into an assembly operation or actually completing the assembly themselves. And then production and efficiency reporting and the whole logistics of what can be a very complicated supply and delivery chain. Right? So those are the major technologies that we've seen implemented or that the survey respondents talked about. Robotics has been in use since 1959, and you know, these are the areas that they tend to be used in the plastics industry. Assembly, packaging, and also part differentiation. That's becoming really important, by the way, because one trend in the industry that I suspect some of the plastics companies that may be online are aware of is that product diversification is actually becoming a major market pressure now for companies. Customers are looking for more variation in the product. That means mass customization. That means being able to produce several different variants of the product, maybe with the same tooling setup or similar tooling setups. And in that realm, robotics and mechatronics can take on an ever-increasing importance and significance. I won't spend much time on this. This is basically the industry 1.0 to 4.0 presented just in terms of the type of sensors that are available and the development of sensor technology. And right, so automated guiding vehicles, you know, so I won't say the name of the plant, but I was in a plastics processing plant many years ago, and I found myself actually being surrounded by these assembly automated guided vehicles who were delivering tooling, they were delivering tools, they were delivering sometimes even materials or specialty inserts to the molds. You could imagine the types of technologies that apply to this, you know, self-learning, for instance, these assembly or automated guided vehicles actually communicating with one another. And so I mentioned color blending, and you know, there's various different ways of blending colors in an injection molding system. And we're seeing definitely a trend away from any kind of manual mixing. So all the way from proportional vacuum loaded blending down to gravimetric blending, which is probably the most accurate one, right? And also an increasing use of hopper loaders. That definitely fits within the whole area of mechatronics, because you're using a mechanical system with sensors to optimize how the process functions. So we see a lot of assembly equipment being more and more implemented in the plastics industry. One trend actually that I don't mention on here is the increasing use of air skin robots. So handling plastic material can involve, you know, you don't want to apply too much pressure to the material as it's being handled through the system. Otherwise you could damage it. So air skin robots are used basically for two reasons. One is to make sure that you have control over the amount of pressure that's applied to the polymeric material. But also if it's a kind of a core robotic situation where it's working side by side with a human, the air skin actually can prevent injury. It's a kind of a, you know, a safety expedient. RFID has existed for a long time and goes all the way throughout the system. So from inventory scheduling back into the supply chain, distribution and transport. And just quickly, I wanted to mention this as well. So this is actually a study that was similar to what we did at Penn State Behrend, where these A, B, C, and D represent 4 different companies in the plastics industry of various sizes, actually. That's the discriminator mostly. But I wanted to show what the most acknowledged drivers were, right? And so everybody is looking for cost reduction. But interestingly, the most acknowledged barrier is a lack of employee knowledge about Industry 4.0, and more specifically, robotics and mechatronics. And that went right across all of the companies. And then, you know, one of the most challenging readiness things that came up in many of these surveys is just the motivation and the understanding to implement these technologies that are out there. They can definitely make a difference. It's been shown that they can make a difference. And one thing I'm not quite sure, oh no, actually, I wanted to get back to our own survey as well. I think I might have inadvertent, oh yeah, okay, Logistics 4.0, which we've already talked about, you know, so that is essentially implementing industrial Internet of Things entirely throughout your supply chain and all the way through your distribution network. But let me just get to, you know, the kind of bottom line findings from our survey. Various advantages that we talked about already in, right? But not really perceived to affect sales, but definitely affects process efficiency. The implementation actually correlates with company size, and that was sad actually. One of the things that we found out is the smaller companies probably could benefit more than the larger companies, but obviously because of resources and disposable capital, it was the larger companies that had the more opportunity to implement. And so those were the major findings, and what I would say is that our perception of it is that there is huge opportunity for implementation of mechatronics, particularly in the plastics industry. There's definitely some technical barriers, but they can all be overcome. The major barrier seems to be a lack of knowledge, right, of what is available, and a lack of training, right, all the way down to the shop floor. Okay, so I'll leave it at that, just to give some time for question and answering. I mean, I realized that was a kind of a little bit of a drink from a fire hose, but I'm sure Johannes and I know that Johannes will be happy to answer any questions that you might have.
All right, thanks everybody. We're going to transition, as Greg mentioned, into the Q&A session to round out our live webinar today and stay on track with time as we're rounding out the week as well. So again, I just want to take a minute, give these guys a break, and come back to our audience here that we have with us today. You know, so we're rounding out the week. I hope it's going well for you. I'm enjoying your summer. And as we're all talking about, we opened up with evolution, change, partnerships, neighbors, colleagues. So we want to thank you for joining us today and allowing Greg and Johannes to inform us with their knowledge on this evolving industry and technology that we can hopefully continue to drive in our daily operations and our resources. much as what the Plastek Academy is here for. So as you may know, you've been with us before. If you're new, standard Q&A session. We're going to go live here in a few minutes as we let your questions come in. Please use the chat box on your dashboard to type in those questions, and they will be coming right into us here, and we can get those answered for you. So if you have any questions, please take a moment to do so, and we'll see what comes in. I know that coming from a marketing and human resources side of things, assisting the sales, and as well as working with our employees here, being from the Erie area, neighboring Penn State Behrend, again, we thank you for being the experts in the educational realm and partnering with us in producing these new avenues of resources. So it kind of hit home for me. Again, we opened up with the challenges and benefits, training, ROI, the buy-in. You know, anything that's successful, we've got to have the buy-in from anybody that we want involved to help us support that. So we do have a couple questions that can connect that opening statement of what we're here to discuss and the end kind of survey charts that Greg shared with us with the feedback that came in. What are our challenges and what are our pain points? So why don't we start off with a question here. The presentation defines the technologies that have or might be applied in improving productivity. Have there been studies that quantified the likely return on investment? So going back to that ROI.
Yeah, I can take that one, Nicole. I mean, so the data that we showed on return on investment was for manufacturing broadly. It wasn't particularly for the plastics industry. And so I would say that that's kind of one of the disappointing things that we found, is that not an awful lot of data has been shared publicly about what the actual return on investment has been for the plastics industry more broadly. Okay, just the plastics industry as distinct from manufacturing industry broadly. That's kind of disappointing. My intuition is that because the plastics industry, particularly the injection molding industry, generally operates on such small margins and generally such high volumes, that I would say implementation broadly of robotic technology is as advanced in plastics industry as it is any place else. So I think those data are available. I think that they exist somewhere, but I wasn't able to find any kind of a public resource that says this is the ROI that specifically applies to the plastics industry.
Okay, great. So we'll continue to keep those connections, keep those neighboring partnerships as resources with where we can get that information. You know, if you guys are in there in the industry, we all love to network as we're doing here today on our webinar. So just keep chatting, keep talking, talk about experiences, challenges, pain points, and solutions. So hopefully one day we can make that, you know, continue to make it public. Okay, our next question. All right, so this may or may not talk, adding a little bit of fluff to the question. You had mentioned the benefits for larger companies versus smaller companies who have begun to implement this. As we know, there's so many different avenues and types of implementations where it can be from forklifts to robots to programming, you know, any size piece of equipment. The question is, to what extent can existing manufacturing systems be retrofitted for efficiency? And the second part, does implementation usually entail acquisition of entirely new manufacturing systems?
I don't know, Johannes, do you want to take like an initial stab at that? Do you have any perceptions of that? I definitely can. I have some perceptions.
I'll start, Greg. I think in terms of implementation of mechatronics and what with some partner companies, what we saw was that the low-hanging fruit is extracting value from data analytics, whether it is routing your incoming material or scheduling different works machines and work centers. A baseline manufacturing data analytics and a simple dashboard. It doesn't have to be very complicated. Excel-driven dashboard significantly, we have seen it, improves overall process efficiency, throughput, and also production worker efficiency. Or in some instance, we have seen, and it has been reported by our partners, a 90-day payback time on manufacturing data analytics time investment. In terms of legacy equipment, companies don't have to buy new equipment in general. Existing or legacy equipment could be retrofitted, with add-on capabilities. You have wireless sensors, for example, whether it's vibration, noise, temperature, that could be extracted and value added or value extracted from the data. So these are, the low-hanging fruit. Greg, anything you want to add?
Yeah, thanks, Johannes. I think that's a really great perspective. That's similar to what I was going to say. And in fact, just kind of springboarding off your answer, many years ago, I visited a company that's involved in recycling of metal. And I was astonished to see this quote unquote dirty manufacturing environment, right? Okay, so you could imagine basically steel smelting, recycling, not a very, very pleasant environment. But all of these advanced sensors that had been put in different locations to send, to sense the temperature of the billet, to sensor the pressure that's actually being applied through the forge, all of this type of stuff, which was all very new technology and very simply, very simple data analytics that were applied to it. I'm glad you mentioned Excel. There's an awful lot that you can do just with Excel that most people have. So it was astonishing to see how much new technology had been retrofitted into a very old and a very traditional industry going back a century.
Greg, I think, and if I may add, we come along companies and work with them. Right. That's what we do. Whether implementing the baseline dashboard data analytics or training in automation, robotics, even we come to the factory floor and work with our partners. We work with companies to do that. I don't know if Michelle is in the audience, but she can say more. We do that. We work with hands-on. As Greg said, we came from industry. We have spent years and years working in the manufacturing floor. So we love to come along companies and address prevalent issues by working together.
Very good. Sounds like that was a great question and took us down a couple different avenues there. And I am watching the time for be respectful of our audience as well as our experts here who are gearing back up to get back into the school session. We've got one of them on the road. So I think that we will end with those two questions. We'll have a bit of a plug here for each Plastek and Penn State Behrend with our final comments coming up here today, guys. But just a reminder to our audience, if you have any questions that you weren't able to answer, we do have or even ask today, we have our contact information up on the screen, so please make note of that. And any of us will be happy to get back to you via email and further with what you need. So a little bit of a plug. I'm going to hand it over to Greg and Johannes to say final comments and how Penn State Behrend can continue to be a resource to you guys. And then I'll take it with the Plastek Academy. And we thank you. Thank everyone.
Yeah, I would just say, that one thing that we pride ourselves on at Penn State Behrend is our willingness, actually our eagerness to work with industry and solving real problems. And we do that for two reasons. One is we definitely want to benefit local industry particularly, but it also creates a fantastic experience for our students. And bear in mind that we have students across 10 different engineering and technology programs. And we also have business students. We have an interdisciplinary business with engineering program as well, right? So any way that you'd like to engage with us, we have an open laboratory attitude. We have an open laboratory philosophy here. We try to break down as many of those barriers as possible between academia and industry. And like Johannes said, we both have a lot of industrial experience, so we understand that perspective.
Johannes, any parting words?
I think I will add what Greg to what Greg said. We want to come alongside with industry and work with you. We have a fantastic additive manufacturing lab, Industry 4.0 working group and lab, and with a collaboration with Plastek, we are improving and increasing our capability in terms of mechatronics, automation, and robotics. And our students get engaged, and it gives them an opportunity to learn and also address industry and business problems. So if you need any help, or if you want to, if you are interested to work with us, please reach out, and we'll be more than happy to work with you.
Thank you. All right, everyone, we're going to finish up with our last slide here before we let you go today. Again, thank you for attending with us, and we thank Penn State Behrend for continuing to be in our own backyard. We are here in Erie, Pennsylvania on Lake Erie, and as we are place a lot of value and investment into personal development, career growth, education, training. You know, we are happy to do our part, and we're happy to partner with Penn State Behrend to continue that and continue to tackle some of these barriers and challenges. So whether you are active in a career role and just looking for that personal development, or you're a student wondering how you fit in, I'm amazed. I've been amazed over the last 10 years working with Plastek, how much broader of a spectrum, you know, certain talents can fit into manufacturing, the shop floor, you know, from business to office to programming to Excel. You know, I heard the word Excel today. So take those skills and share this with any of your colleagues, coworkers, students, anyone in the community that we can help better. So continuing education, we have a few more webinars left in our series this year listed on the screen. Greg hit on one of them that we're going to close out with, cybersecurity. We have another vendor that we partner with, so we'll be emphasizing a bit more on cybersecurity. We're going to go backwards a little bit, back to the materials with the plastics, raw materials, and the outlook for 2023. And then next month, using our finished products to continue to be a world-class supplier and global manufacturer, and shipping out our finished goods with making sense of logistics. So we hope that you join us throughout the rest of this year. And as we continue to evolve, we do have a quick survey at the end. We've added a few new questions to help us continue to evolve and look forward to 2023. Until next time, thanks everyone, and have a great day.